All right, we're ready for page 2 in section 10.1. And this page we're going to look at graphing equations that involve radicals. So the first function, we have a function here, f of x is square root of x plus 2. So what I'd like to do is to make a t-chart, and we'll find some points and try to see what this looks like. We'll identify domain and range, and we'll, of course, graph it. So let's x and y, right? So let's plug some numbers in for x. So let's think of nice numbers. 0 is always a good idea, right? Let's plug in 0. Square root of 0 is 0. Plus 2 is 2. Let's try 1. Square root of 1 is 1. Plus 2 is 3. Now if you stop at this point and say we have 2 points, that's enough, you would be wrong, because this is not a linear equation. If we have a radical involved, it's not going to be a line, and so we're going to have to get probably more than 2 points to get an idea of what this function actually looks like. Could we plug in 2? Well, square root of 2 is not a pretty number, so let's not plug in 2. Square root of 3, still not a pretty number. The next perfect square we run into is actually 4, right? So let's plug in 4. Square root of 4 is 2. 2 plus 2 is 4. So we have 3 points there. Let's go ahead and plot those and see what we get. 0, 2 is right here. 1, 3 is right here. And then we have 4, 4, which is right here. As you can see, this is not a line, right? Those 3 points do not fall in a line. If we had one more point, the next perfect square would be 9, right? Square root of 9 is 3. 3 plus 2 is 5. Now I know we don't have a 9 out here, but if we had one, it would be right around here. And we'd have a point at 9, 5, which would be right about here, right? Now, can you plug any negatives in? If we plug in -1, for instance, well, we can't take the square root of a negative, which means we can't have any negatives, so there are going to be no points over here. In fact, the first x value we can plug in is right here. That's kind of our starting point for the graph. And then, but we can plug any positive number in. And so we get a graph that looks like this. All right. It's a nice smooth curve, and this is what this particular square root function looks like. Once you have the graph, domain and range should be easy, right? Domain, well, we go left to right with domain. What's the furthest x value on the left? It's 0, right? 0 is the smallest x value, and that point is included on the graph, so we have a bracket with 0. And then this goes off to the right forever, so we go off to infinity. The range, what is the smallest y value? Well, it appears to be 2, right? And then it goes up forever, however slowly, it's going to go up to infinity. So your range is 2 to infinity. All right, let's graph a cube root function. Right, I'm going to make a t-chart again. If we're going to graph a cube root function, it's a good idea to plug in perfect cubes here. And 0 we can still plug in, right? Cube root of 0 is 0. 0 minus 2 is -2. We could plug in 1. 1's a perfect cube, right? Cube root of 1 is 1. 1 minus 2 is -1. What's the next perfect cube? Let's see. 2. Cube root of 2 is not going to be pretty. Cube root of 3 is not going to be pretty. Cube root of 4, not going to be pretty. The next perfect cube, if you think about cubic numbers, 0 cubed is 0. 1 cubed is 1. 2 cubed is actually 8. And so 8 would be the next perfect cube. Cube root of 8 is 2. 2 minus 2 is 0. So you might plot these points. We have a point at 0, -2. We have a point at 1, -1. We have a point at 8, 0. So you can see again, this is not a line, is it? Now is that it? Can we plug in negatives? With a cube root, when this is an odd root, we can plug in negatives. So let's plug in maybe -1. The cube root of -1 is -1. -1 minus 2 is -3. So we have a point at -1, -3. What's the next? Now if I just look at these 3 points, it looks like a line, doesn't it? But if that's the only 3 points we plotted, we would be misled into thinking this was a line. because we have a point out here, right? The next perfect cube, if we're looking at negatives, is going to be the opposite of 8, or negative 8. If we take the cube root of negative 8, we get negative 2. Negative 2 minus 2 is negative 4. So we have a point at negative 8, negative 4, right in here. So we need to make a nice smooth curve that passes through all these points. I'll do my best to do that. And I shouldn't have went above that line there, but there we go. So this is what our cube root function looks like in this case. Now we can talk about domain and range. Domain, it goes clearly left forever and right forever. So negative infinity to infinity. And it also is going to go down forever and up forever, however slowly. So again, we have negative infinity to infinity. One more question on this page. We're asked to find domain and range of this function. We're not given a graph. You could graph it to help yourself out, but there's another way to do it. We could plug any number in for x as long as you could take the square root of this expression underneath. So if you ask yourself, what can I actually take the square root of? Well, I can take the square root of any non-negative number, as long as it's 0 or positive, right? So this x minus 3 that's underneath the radical has to be greater than or equal to 0, right? So if we solve this inequality, it will give me the domain. Okay? So this is going to tell us the domain if we solve for x, right? So let's solve for x. We add 3 to both sides, so x is greater than or equal to 3, right? How do we write that in interval notation? Well, if it's greater than or equal to 3, then that means 3 is the smallest number in this set. And since it could be equal to 3, we have a bracket with the 3. X could also be anything greater than 3, so we go off to infinity. So that's our domain. The range is just a little bit harder. So what could the y values be? Let's see here. So if you think about the y values, when you take the square root of a number, so y is equal to the square root of something, right? Square root of x minus 3. So if you take the square root of a number, what kind of numbers can you get? Well, when you take the square root of a number, you can never get anything that's less than 0, right? Square root of something has to be greater than or equal to 0. So what we can say is y has to be greater than or equal to 0. Solve this inequality. Well, it's already solved, right? We just have to say, well, 0 is the smallest number it could be, and we could go off to infinity. So this would be our range. Domain, 3 to infinity, range, 0 to infinity. Again, you might find it easier to graph first and then look at domain and range. I could graph this. If you think about points we plug in for x, we can't plug in 0 because 0 minus 3 is a negative, and we can't take the square root of a negative. The smallest number we could actually plug in would be 3, right? And that's clear here. So we'd have a point at 3, 0, because square root of 0 is 0. So 1, 2, 3. Point at 3, 0. We could also plug in 4, because 4 minus 3 is 1. Square root of 1 is 1, right? So we could plug in 4 and we would get 1. So we'd have a point at 4, 1. And then we think of the next perfect square. So we had 0, we had 1, we had 4, right? Square root of 4 is 2. So how could we get 4 underneath here? We'd have to plug in 7 for x. So we have 1, 2, 3, 4, 5, 6, 7. If we plug in 7 for x, 7 minus 3 is 4, and square root of 4 is 2. So we have a point at 7, 2. All right, so we can make a nice smooth curve through these points. If we look at that graph, we can see the domain is 3 to infinity. Starts at 3 on the left, goes off to infinity on the right. If you look at the range, 0 is your smallest y value, and it's going to go up forever, so we go to infinity. So you might find it useful to graph the equation to find the domain and range, but it's not completely necessary. I like to graph to verify that what I found here is correct, but you may find to graphing it first and then finding domain and range will work better for you. So that's it for this section. We'll see you in section 10-2.